As you've probably seen in a video a couple years ago, we originally built this cover here over the fire pit area. And what we realized up here is we're never really out around the fire pit now that we have the building when it's shitty out and pouring rain. We did this at our beach property. We have a lot of people we share that with. We do find there, you know, because we have trailers and stuff there instead of buildings, that we're out when it's raining a lot. So it actually works really good. So what we're going to do is we're actually going to move the fire pit area over on the other side there, and it'll be outside again. We'll probably build that out really nice with benches and stuff. Was the plan here originally. And then once we move that out, all the firewood will go to a new building on the other side of the container. And then we're going to actually use metal from the same kind of metal that you can do with these carports, and we're going to cover this thing up and close it in. Inside we'll have all the water tanks. We will have a pump house which stores the pressure tanks and the filtration. This whole system will have its own solar, so I'll put some panels up on the roof of this. So basically it's a self-contained thing. All the water that hits this roof will drain and fill the water system. The overflow from that will go down to the orchard tanks. Tanks are black, they're protected from the sun, but inside they'll never have, you know, heat issues, anything. They should be pretty good in there. So it was kind of a good use of this space. Originally this wasn't even level, it was just a hill, and we had them level it when we put this in. But as we said, it's this property, the whole thing's an experiment, and we're going to change it as we go. So that's the current plan. So we picked up the water tanks for the catchment system. We grabbed two 1,550 gallons each, so that should give us about 3,100 gallons. And actually grabbed a couple IBC totes as well. Like I mentioned, we had been talking about doing it all in IBC totes, but it was just so much more plumbing and so much more work. So a little bit more cost. The main thing about these tanks is like the 1,000-gallon tanks are only $70 less than the 1550s. So it's kind of a no-brainer just to get the 1550s. Anyways, we got them all loaded up. I'm going to haul them up to the property, and we'll get ready to get started on this water catchment project. Well, we made it all the way up. Tanks are here. No issues on the way up. Seems to be pretty good. Kind of got one little squish there, but should be fine. It'll pop back out, especially once it's full of water. So gonna unload all these things and leave them here till we're ready to put them in. They'll be going in over there. Picked up a couple of IBC totes. These are 275 gallons each, and they have the cam lock valve on them down here, which you can connect all kinds of things to. These are actually triple rinsed and food grade in case we wanted to use them for potable water, but we may not. You know, the big tanks will be for the main water system, but the overflow from the catchment system for the main water supply will go down and fill these things down in the orchard, hopefully, or tanks near the orchard. So we'll catch the overflow and fill these up, and these will be great for using water to watering the orchard while it's young, you know, until it can take off on its own. So we may need water elsewhere on the property, so these are great for that. So while I was there, I grabbed a couple. Actually not very expensive, and they're easy to move, so they're nice to have around. A couple things about the IBC totes also is make sure that the pallets, so it's a tank inside a cage, the pallets they sit on can either be metal like this one is, or they can be like a resin, plastic, or a vinyl like that. Don't get the wood ones, because the wood pallets, like everything wood, will eventually rot, and then the thing's not sitting on anything. So when you're buying them, if they're super duper cheap, there's probably something wrong with them. Either they are not food grade or they are wood pallet based, so be sure to check that. We have these two 1,550 gallon each tanks right here. Water catchment is coming off of this metal building through there, goes through a filter to keep mosquitoes from getting in there, mosquitoes getting in, down into here. We plan on replacing this. This was to get it up and running and fill these tanks before, you know, the rain season ends, which is still a ways out, but we'll probably redo this and put an actual like leaf catcher and first flush in that. So right now, this metal building is being used to catch all the water. We didn't use the cabin because it's got asphalt shingles and we just didn't feel like that was a great idea. Plus, we filled both of these tanks so fast, like it was unbelievable. So kind of not too concerned about it. We are only catching water off this half. We don't even have this gutter hooked up yet. It's still draining out the hill. So this half by itself filled these tanks, you know, with just pretty typical rainfall of the year in like a week. So it was no big deal. And then we've been here for about 5 days. And since we have the temporary hose hooked up and a pump, we've been taking showers and stuff, and, you know, tanks fill right back up. I also pumped water out of these into the 2 IBC totes just to have water set aside there for things like probably the pressure washer or whatever we need down the road. But these two filled right back up in the last day or two, so not too worried about it. We do have space here to add another tank. We can put a third one right here. So how this is set up right now is there's a valve at the base of each tank, so I can shut either tank off. There's a valve on each end of the line. This right here connects to the overflow and goes out down the hill. So the overflows are here. I mean, you don't have to hook up both sides. I mean, because it'll go out one side or the other, whichever one's higher, I guess. But it was easy to do, and I just wanted to have it, you know, as good as could be. So plumb both of those down. This valve here stays closed. The idea here is that if I have to drain one of these tanks, I can open this valve and it'll drain out through the normal overflow. So I could shut that tank off, open this one, you know, shut the house off or the cabin off, and then turn that, and I could drain that tank without draining that one, and vice versa. So that might be handy someday if we have a tank problem or we have something goes bad. So, and then over here we will have this main shut off, and like I said, it'll drop down right here into the ground, go over into the building. Well, we got the utility building all finished up. Well, mostly I need to do some metal trim pieces down the front and back there. It's covered by this other metal, but it does drip and stuff from condensation, so I just wanted to protect that, and wind blowing in. Eventually we'll side in the sides of this, but not right now. But we did get this building up yesterday, and it's all ready to go. It's kind of a weird dimension. It's like 10 by like 7 or something. But it was nice since we built it ourselves. We could make it fit in the spot. Off-grid water catchment system, some assembly required. So the water system, which is actually up right here, ends right here. We actually have a hose temporarily hooked to it, which runs over to a little pump on the deck. So the cabin is actually running hot water and everything, just off this little hose, pulling water from both of these 1550s, which are absolutely completely full because we've had lots of good rain. This system will drop into the ground there, go underneath here, and come up inside the building right here, where we will run into the spin down filter right there. So the feed out of the main tanks, you can see, goes underground there and comes across here. We'll be building a box over all of this to protect it, as well as I want to put some tape type heater strips on that to keep it from freezing in the winter. So that's the next thing to do. It comes up into here, and then we've got a shut off. This is a spin down filter, which picks up big particulates. It's pretty cool when it's running. You can see everything spinning in it. Backflow prevention, another valve to shut off so I can isolate either side. This is the booster. It's actually not like a shallow well pump or a well pump, because our tanks are pretty much level with this building, slightly below it actually. But we're not pumping out of a well or down up a hill or anything. So we just use this as a pressure booster. So this is from Gondafoss. I'll post a link to it in the description, but basically this just builds up pressure, pulls water from the tanks, builds up pressure. Pressure tank, obviously, so we can hold pressure. We've got shut-offs on either side of it. It's got a high-pressure relief there, so it'll just flush under the building. And a little here if I need to hook a hose up and drain things. Shut-off here. The big thing is this filtration system, so we put shut-off valves on either side of it and here, which lets us isolate it. So I can open this, close these two, and that isolates the system. So if you're changing any of the filters, you do that so that you don't have all the pressure from the water system coming in through here. This is a US Water Systems filtration system. It's a 5-stage. We're doing like a 5 micron or radial flow carbon type thing, 1 micron, and then this interceptor filter here. And then that comes out and goes into this, which is ultraviolet UV, which you definitely want. This is what kills all the bacteria. So get all the particulates and metals and crap out. Now we are getting rainwater, so, you know, this might be a little overkill for rainwater, but you never know what's going to get in the tanks. And, you know, this system versus maybe a 2 or 3 filter really isn't much more. So I was like, let's just do it right. This system here, this is the control box for the ultraviolet. There's a lamp inside here, comes out the side. You can actually change this lamp out without depressurizing. And then water lines come back over here to this side where there's a final pressure gauge here. This is a pressure regulator, so we run the booster in the tanks run about 65 psi. I knock it down to about 50 with this thing, so I can adjust it higher or lower if I want, and that runs out underground all the way to the cabin. This is a water spigot outside that I put here just for convenience, so it's got its own shut off here. So that's pretty much it. Not super complicated. It was one of the first things I've had to build like this, so it was actually a lot of fun, and I really enjoyed doing this project. So far it's worked great. We've been running it about 4 months. Not really had any problems, so we'll see how it goes. We'll keep you posted. This building actually has its own power system, so I could have just pulled power from the main building's power system over to here, but the reason I did not was I don't want the pump, whenever it turns on, it has a really big draw when they fire up. I don't want that power pole hitting the main system, because then it causes things like, especially LED lights will dim a little or they'll flicker every time. Super annoying. So originally I was just going to put solar panels over here, make it a dedicated system separate from everything else in case something happens. But then what I decided to do is I was like, well, I'll put all this in its own battery bank, small battery bank. That'll absorb that initial hit from the pump. And I just feed power from that building over here as AC. So I just dropped a big gauge cable from right at the edge of the building over there, ran it underground over to here. So it actually comes in, feeds this charger right here. It's a Blue Smart charger from Victron. This is the inverter that runs the whole building. I've got a servo in here so I can monitor it and get to it remotely. And then obviously a smart shunt for DC monitoring. These batteries are amazing. These are from Renogy. These are 300 amp hours each. So I got them in parallel so they can do 600 amp hours, which is amazing out of these little things. Just a little 12 volt, they can do 300. That's one of the biggest ones I've seen. These are lithium iron phosphates. So I have 2 of these in here. And that pretty much absorbs all the hits from this building. Also, if the main building is having problems, this building can still run till it runs out of power. I also have the ability to swap the power coming from the building. I can swap it out and hook a generator to it. The other advantage too is that if there's power problems everywhere, the big generator on the other building will power this one. So, you know, it'll come out of the inverter on that side, come over here, go back to DC, and then get reinverted. So sounds super inefficient, but it actually works really well, and I didn't have to put a bunch of more solar panels on. The other cool thing I did was I have the power coming out of the inverter into this box. One side switched and one side is not. The switch side, this little tiny guy here, connects to a switch wirelessly to a switch inside the building, and inside you can push that switch and it will turn these outlets off on this side. So out there I can remotely shut the pump down in here. So what this does is it actually shuts that pump off and it turns the UV off. The main thing I wanted to do was turn this UV off because you get about, I think it's 9,000 hours or something, a little over a year out of a bulb. And when we're not here, having that bulb running there's no point, because once it's killed any bacteria in this tube, if the water's not moving, it's dead. So having the bulb running when we're not here for a week or whatever, or 2 weeks, just wastes its life. So I wanted to be able to shut it off remotely, so when we leave, I can hit a switch in the building. I don't have to come out here. Shuts that off. The reason I shut the pump off is so that you can't run the water for very long if you forget to turn the switch on. So when you come back up here, you forget to turn the switch on. That's not on. That thing will still have pressure in it, so you'll still push some water into the building, but the pump will never start. So you'll be inside, all of a sudden the water pressure will drop. You'll be like, oh yeah, I forgot to turn the switch on. So that was kind of my pseudo prevention from running, several days without this turned on because you forgot to turn the switch on. So